Hello friends, today we will be observing basics of a Smith chart and basics of the stubs. So Smith chart is an impedance and admittance chart which is designed to use the impedance matching networks at a high frequencies. So if you observe the Smith chart, there are some horizontal circles running from a left hand side to the right hand side. These circles are called as a constant resistance circle. That means you can see the values of these circles are written on a horizontal line on the chart. For example, this is 1. The circle running from this 1, this is called a R is equal to 1 circle. This is called as a R is equal to 1 circle. The circle running from point 5, that is called a R is equal to 0.5 circle. Circle running from a point 2, that is called R is equal to 0.2 circle. In this way, if you see the values of this constant resistance circles or resistance circle goes on increasing as we move from left hand side to the right hand side. So at the left hand side at this point the R is equal to 0, as well as at the right hand side at this point R is equal to infinity. R is equal to infinity. So the value of R goes on increasing from 0 to infinity as we move from left hand side to the right hand side. Similarly, you can observe some vertical circles are also running from top to the center line on the Smith chart. So these vertical circles are called as a reactance circle, or they are also called as a JX circles. So positive Jx values are represented in the upper half of this Smith chart. So you can observe that is this is a plus j.2, this is plus j.5, this is plus j1. In this way you can see like this is plus j0. So you can see like this, if we move from the left hand side to the right hand side, the value of the reactance, that is jx value, goes on increasing. Similarly, there will be the negative reactance also there, that is minus jx values. So these minus jx values are represented by the vertical circles running from bottom toward the center line, and this will represent a minus jx value. So likewise, there will be the minus j.2 circle, this will be the minus j.5 circle, this will be minus j1 circle, this will be minus j2 circle. So in this way these values also goes on changing as we move from left to right hand side, same as that of a plus jx values. So when we want to plot any point on the Smith chart, then what we have to do, we have to plot with respect to r and jx values. For example, if you want to plot the impedance z, which is equal to 1 plus j1, so that indicates that this 1 indicates this is r, and this j1 indicates the jx value. That means we have to move r is equal to 1 circle on vertical circles, r is equal to 1, and for on horizontal circles we have to move on r is equal to 1 circle, and for vertical circle also we have to move on j x equals to j1 circle. So if you want to plot this point on a graph, then what we have to do, first we have to find out where is 1. R is equal to 1 circle on a horizontal line. So this is your r is equal to 1 circle, as it is plus jx. So we have to move on r is equal to 1 circle in upward direction, and we have to move in the upward direction in this way. Similarly, the jx value is plus 1. So what we have to do, we need to find out where is jx is equal to plus 1, this one. So on this circle we need to move in a downward direction. The intersecting point of this horizontal circle and the vertical circle, this point will be equal to 1 plus j1. Okay, in this way we need to plot the point on this Smith chart, impedance points on this Smith chart, and whenever we are reading any position of the impedance point, and also we have to use the same method Like first we have to see the point lies on which horizontal circle. Point is lying on r is equal to 1 circle. So you need to write 1 first, and then if the point lies on a upper half of the Smith chart, then we have to write plus j. Then we have to search for on which vertical circle this point lies. So as it is lying on plus j1 circle, we have to write 1 plus j1 is its value or its position for this point. In this way, we can plot various points on a Smith chart. But see, many times what happens, like these points are not having the values like 1, 2, 3, 4. Z is not having, impedance is not having the values like this. So what we have to do, we have to, whatever the values of the impedance, so we have to normalize that values, and then we have to plot it on a Smith chart. Then how to normalize these values? For normalizing these values, what we have to do, we have to divide each and every value of Z L with the characteristic impedance. For example, if the characteristic impedance is a 50 ohm, then, and if the ZL value or a load impedance value is 100 plus J50, then we have to divide this 100 plus J50 by 50. That means each and every component of the Z is divided by 50, that is 100 divided by 50, that is equal to 2, and J50 divided by 50, that is equal to 1. So the normalized value for the Z1 will be equal to 2 plus J1. So this will be your normalized value. In this way, for all these various values of the load, we can calculate the normalized value by dividing it by 50 ohm characteristic impedance. That is Z2 is equal to 75 minus J100. It is divided by the 50. So that will become 1.5 minus J2. Similarly, J3 is J200. So there is no R value. So what we have to do, we have to divide only this 200 by 50. So Z3 is equal to J4. Now see here, Z4 is equal to 150. There is no Jx value. So we have to divide only this 150 by 50. So Z4 is equal to 3. Now Z5 is infinity. We know that for the open circuit load, the impedance is a infinity. So we have to, if Z5 is infinity, we have to divide it by 50. So final value that we are getting it, that is a infinity. Z6 will be 0, that is a short circuit. For short circuit load, the impedance is 0. So Z6 is 0. So 0 divided by 50. So Z6 will be 0. Similarly, if Z7 is having value equals to 50 ohm and we want to divide it by 50, that means Z7 is equal to 1. In this way, Z8 is equal to 180 minus J900. That will be divided by 50, that is 3.68 minus J18. So these will be the normalized values. So like this, we have to convert the actual values to the normalized value by dividing it with a characteristic impedance. So likewise, first we need to convert all values to the normalized value, then we can plot it on the Smith chart. So if you want to plot it on a Smith chart, we have to use the same method. Like first, we have to see what is the R value in this. That is, this is 2. For example, in Z1, it is 2. And what is the Jx? Jx is plus J1. So what we have to do? We have to move on a horizontal circle, a horizontal line. We have to find out where is 2. Where is 2 on the horizontal circle? Here it is 2. So we have to move upward on the 2 circle, and then Jx1. So Jx1 circle is here. So we have to move down on this circle, and we have to find out the intersection point of both of this circle. And so this is your intersection point. This is Z1. Okay, so in this way you have to plot each and every point. Similarly, Z2 is also 1.5 minus J2. So first we need to find out where is 1.5. So 1.5 horizontal circle we need to find out. As it is minus J2, we need to come down on that circle, and then where it is J2, here it is J2 on the minus J2. So this is minus J2, minus J2. On this we need to move in a upward direction. So intersecting point will be Z2. So in this way we need to find out the, and we need to locate the Z2. Similarly, Z3. Z3 is having only Jx value. So where will be the Z3? Z3 is this point. That is only J4. This point. There is no R value. So this will be only J4. That is Z3. Similarly, Z4 is having only value equals to 3. So where is 3 on a horizontal line? There is no Jx value. So only we need to consider the R value. So this is only 3 value on the horizontal line. So this will be Z4. So this will be the Z4 point. Then similarly Z5 is infinity. So where is the infinity? So this point is infinity. So end point will be the Z5. So where is Z6 is 0. 0 is the start point on the horizontal line is a 0. Similarly Z7 is equal to 1. There is no Jx value. So this will be 1, center point of the graph, that is 1. Similarly, Z8 is equal to 3.68 minus J18. Now this 3.68, this value is not there on the Smith chart. Okay, if you see the horizontal line 3.68, that number you can't get it directly. So what you need to do? What you need to do in this case? In this case, you need to find out the horizontal circle is horizontal circle in between 3 and 4, 3 and 4. Then what you have to do, you have to go down in between 3 and 4. You have to draw the circle with a hand parallel to the 4 circle, parallel to 4 circle, and then minus J18 circle, J18 line, you have to go upward, and then you need to plot this intersection point as a Z8. So in this way you need to plot the various points on a Smith chart. Now for all these points we need to, many times we need to find out the distance on the Smith chart. We need to find out the wavelength related to these points. Then how to find out the wavelength related to these points? So for this what we have to do, if you want to, for example, if you want to find out the wavelength at this point Z1, then what you need to do, you need to draw the line from the center of a graph, that is 1 to 1, then Z1, line passing from center Z1 and out of the graph. So out of the graph there will be the one circle, that circle is called as a wavelength circle. So we will see where and this line will intersect the wavelength circle. Where it is intersecting, that we have to read it as a wavelength for that point. So where is the wavelength circle, that we will see first. Now see, on outside your graph you can see on the center line there is one number is written like 0, 0.0. Okay, then on the right hand side the number is written, that is 0.25. Okay, now if you see J, if you see J1, so on the J1, this is point J1, J plus 1. So if you draw the line passing from this point J1, here it is written 0.125. Okay, so you need to locate this circle which is having these values. When we are moving from left hand side towards and right hand side, on the left hand side there is 0, 0 written on that circle. On the right hand side it is written 0.25, and this circle on the K is equal to 1, that is at a 90-degree point, it is written as 0.125. So this circle, you have to go over this circle, this complete circle. Now J is equal to minus 1 point, it is written as this point 0.375. So you need to trace all these values, circle passing through all these values, 0.0, 125, 0.125, 0.25, 0.375. So if you draw the circle, if you go over this circle, whatever the circle you got after tracing all these points or after connecting all these points, that circle is called as a wavelength circle. That is called as a wavelength circle. And if you want to find out the wavelength at any point, then what you have to do, you have to just draw the straight line from the center, that point, and out of the graph. Then that line will intersect on the wavelength circle. So where that line is intersecting on the wavelength circle, that is the wavelength. That is the wavelength for that point. For example, if you want to find out the wavelength at J1, then what you have to do, you have to draw the line passing from center J1 and out of the graph. So this line will intersect on a wavelength circle at 0.125. So that will be your wavelength at J1. So if you want to find out the wavelength at minus J1, then you have to locate this point minus J1 first. Then what you have to do, you have to draw the line passing from center minus J1 and out of the graph. So this line will intersect on a wavelength circle at 0.375 lambda. So unit for this wavelength is a lambda. So you need to read out a wavelength at minus j minus 1 is 0.375 lambda. Okay, so in this way the circle's total circle length is like 0 0.0, here 0.125, here 0.25, here 0.375, and again the values goes on increasing. Below center line it will be 0.5. Below center line it will be 0.5 lambda. So the total length of a circle is 0 0.0 lambda to 0.5 lambda. So here it is total length is 0.5 lambda or lambda by 2. For total 360-degree, the length of Smith chart in terms of wavelength is lambda by 2. So in this way you have to locate various points on the Smith chart and read out the wavelength related to that point. Thank you.